Hey everyone, I finally finished reading my second book on C++ and I'm ready to share my thoughts about it. There's already a review on the channel of the first C++ book I read, and if you saw it, you know that book was terrible. I dropped it before I even made it halfway through. But now we've got a different book from the same publisher, and this one is much bigger, about 900 pages of content, covers a lot more theory, and it's written with the newest C++ 23 standard in mind. Books like this are pretty rare right now. Let me remind you how my reviews are structured. Before making a video, I read the entire book from start to finish, taking notes on every chapter. Then I record the review where I explain what you learn in each chapter, what's good and what's bad about the book, and who it's actually for. You'll have timestamps for each chapter, so if you're interested in something specific, feel free to skip around. My goal is to find 3 solid big C++ books that can take someone from zero to a decent, confident level of understanding. I'm doing this so that my viewers who prefer learning from books will know which ones are actually worth reading. Alright, let's get started. In the introduction, the author talks about C++ as a powerful, modern, and efficient language that can easily lead to all kinds of errors if used carelessly. But if you study it properly and understand what you're doing, it becomes a genuinely strong tool, a kind of programmer's weapon. I like that the author doesn't ramble. He gets straight to the point. C++ is challenging but rewarding if you approach it thoughtfully. He also points out that the book is based on the newest standard, C++ 23, which makes it current and relevant. The author mentions popular compilers like GCC, CLang, and the one built into Visual Studio, and he recommends using Visual Studio as your main IDE. At the same time, he doesn't explain what compilers actually are. He expects that the reader already has some basic programming knowledge and can install Visual Studio on their own. The author also gives a warning. Just reading the book isn't enough. You have to do the exercises, both the easy ones and the more challenging ones, because practice is what really solidifies the material. I especially appreciate this approach. Books that include hands-on tasks are always more useful than those that only offer theory. We'll see how engaging these exercises turn out to be in the next chapters. In the first chapter, the author keeps praising C++, but this time he actually has a point. He goes over the history of the language, explains how it evolved, which standards came out, and what new possibilities each of them introduced. At the same time, he subtly builds interest by mentioning topics he'll return to later, almost like he's promising that there's a powerful toolkit waiting ahead. Then he introduces us to the C++ standard library and explains that the book will only cover about 20 of its modules, just a small slice of the hundreds that exists. The first hands-on code example appears right here. The author shows the complete program, explaining every line from importing modules and the main function to printing text with println. It's nice that all the examples are also available on GitHub, but he strongly recommends rewriting them by hand to really understand what's going on, and I agree with him. The first technical topic is comments. The author shows both types, single line and block comments. It's simple, but definitely the right place to start. Then he briefly explains what modules are and why we need import std, though this part might feel a bit heavy for someone who's just starting out. Next comes the breakdown of the main function, what it does, why it returns 0, and why the program starts from there. After that, he explains variables, expressions, and blocks. Everything is short, clear, and supported by easy examples. What's interesting is that instead of the usual cout, the author uses print and println, which were added in C++ 23. He carefully explains the difference between them and promises to talk about formatting in the next chapter. Then he briefly touches on the return statement and the concept of namespaces. This is also where he mentions the std compat module, which helps older code look familiar. Then the author suddenly jumps into more advanced topics, identifiers, keywords, and even classes, objects, and templates. This shifts the pace a bit too quickly because the reader hasn't really gotten comfortable with the basics yet and how they're already being shown higher level concepts. Though, for more experienced programmers, this might actually be a helpful refresher. However, the section on code style is a great addition. The author shows different formatting styles, explains why clean and readable code matters, and shares his own recommendations. The explanation of the build process is especially well done. From the preprocessor and compiler to linking, even a complete beginner can get a clear visual idea of what actually happens when they press run. Then, the author touches on the difference between procedural and object-oriented programming. In my opinion, this part doesn't really belong in the first chapter. It makes more sense once the reader already knows what classes and methods are. The final section covers how different kinds of data are stored in memory: numbers, characters, bytes, and bits. It's interesting, but again, a bit early. This material would feel more natural once the reader has already started working with data types in practice. The chapter ends with a short summary and a few simple exercises. Run a program, change a couple lines, and find some errors. And even though it still feels like an introduction overall, you can tell that the real learning starts next. The first chapter is dense and maybe slightly overloaded with theory, but it sets the tone and makes you want to keep reading. Chapter 2. Introducing Fundamental Types of Data. The second chapter is where the real immersion begins. Here we dive into data types and the operations you can perform on them. The author starts by revisiting the basics: what a variable is, how to create one, and how to assign a value using assignment operator, curly braces, or parentheses. There's an example with multiple variables, the one with fruits, and printing them out using println. Along the way, there's a good piece of advice: give your variables normal, meaningful names so you don't suffer later. Next come the integer types: short, int, long, their sizes and ranges. Then the difference between signed and unsigned. After that, char, and why it's better to use it only for characters. He also touches on initialization with curly braces and briefly explains what constants are. Then the section on literals begins: what they are, the different kinds, which suffixes you can add to numbers, and how to use apostrophes to separate digit groups, and how to write numbers in hexadecimal, octal, and binary. After that come operations: addition, subtraction, integer division, and why it always gives an integer, the modulo operator, and why it's useful. There are examples, an explanation of operator precedence, parentheses, and the assignment operator. The author even spends time explaining the difference between mathematical equality and assignment in programming. Then there's a big practical example: converting feet, yards, inches, honestly explained very well. Next up are compound assignment operators and increment or decrement, with the difference between prefix and postfix forms. Then the author moves on to floating point numbers, float, double, long double, and here, in my opinion, he goes too deep. Extra types, precision details, sizes, differences between standards. Useful, sure, but definitely too early. A beginner isn't going to retain that. Same with floating point literals. F, L, it's clear enough, but not something that needs half a page right now. Then there are short sections about std numeric limits and size-off. And then comes the most questionable part of the chapter: math. std numbers, constants, functions for powers, adds, infinity, not a number, and other fancy stuff. The issue is that the reader still doesn't know what functions are at all, and now they're getting hit with advanced math features. It feels like, hey, let's show everything the library can do, but by the time someone writes their first function, they'll have forgotten all of this. In my opinion, wrong place. Thankfully, after that, the author returns to something more practical: type conversion. He explains implicit conversions, why they can be dangerous, and introduces static cast as the clear and correct way to convert manually. He briefly mentions dynamic cast and the old C-style cast. Then there is a deep dive into character types: char, char8t, char16t, char32t, and wchar-t. He talks about encodings, character tables, and especially escape sequences. It's good knowledge, though 99% of programmers will only need it once a year. Still, it's explained cleanly and carefully. But the final topic, formatting, plus print cout, is genuinely useful. The author shows how to format output nicely: alignment, number of digits, fill characters, number bases, and he shows how to do it both with print and with cout. This part is actually on point. The chapter ends with a solid set of exercises. Yes, at times it's overloaded with detail and dives into math too early, but overall, this is where you start to feel like you're actually managing data. Not just printing text, but working with values. Chapter 3. Working with fundamental data types. The author starts out by quickly covering the basics of operator precedence and associativity, shows the full C++ table, and uses simple examples to demonstrate what executes first and when parentheses are needed. He fits all that into basically one page: short, clear, and to the point. Respect for that. Then comes a sharp turn into bitwise operators. It's definitely a tougher topic and not something beginners often need in real-world practice, but it's presented carefully. What these operators are, why they exist, where they're used, plus lots of small examples. Whether that's enough to feel confident using them in debatable, but as a first introduction, it works. Personally, though, I'd save this topic for later, once the reader's algorithmic thinking is a bit more solid. Next up are scopes and verbal lifetimes: local, static, dynamic, and thread local. It's just a surface level overview with the references to later chapters. Right after that, the author dives into global variables, and that's a questionable move. We haven't really mastered functions, loops, or memory yet, but we're already talking about static storage and accessing globals with 2 colons. The explanations are clear, and the warning globals should be constants, not variables, is absolutely right. It's just too early in the book for this. Then come enumerations. Technically, everything great. What enumerators are, how to set the underlying type and assign values, and why std to underlying in C++23 is useful. What's missing is motivation. Why use enumerations when you already have constants? That's an important point, and it would have been better to show it right away with real-world examples. The chapter closes with type aliases, using the old-school type def. The syntax is explained, but the author barely touches on where aliases actually shine for constants, pointers, references, functions, templates, and arrays. Also, he's a bit too dismissive about type def. If you bring it up, at least show a couple of patterns from legacy code and explain where you'll still see it. Overall, it's a solid and informative chapter, but the pacing jumps around at difficulty. One moment, it's a one-page summary of precedence. The next, it throws beginners into bitwise operations and globals before they've really gotten comfortable with loops and functions. The material itself is good. I'd just reorder it for a smoother learning curve, more hands-on practice with regular variables and control flow first, then move on to bits, globals, and type tricks. Now, we've finally reached a really awesome chapter. It starts off simple. The author shows how to compare expressions using the usual operators: greater than, less than, equal, not equal, and so on. There are tons of examples: comparing numbers, small complete programs where we input 2 values and compare them. He even shows how to print a bool so that you see true and false instead of 0 and 1. And he introduces the bool alpha manipulator, which lets you not only print words instead of digits, but also read them in the same way. Then he goes over operator precedence and explains why you sometimes need parentheses to make sure the program compares exactly what you intended. After that, there is a small section on comparing floating point numbers, including edge cases with not a number. And that part is done pretty well. But then he decides to explain the spaceship operator, that three-way comparison operator from C++20. And that's where, in my opinion, he goes overboard. The operator is definitely useful, but trying to cover it before we even started working with classes and structures is just too early. He tries so hard to explain it that he buries the reader under terminology most beginners just won't absorb. I, for one, didn't remember much after reading it. I think he should have just mentioned it, promised to come back to it later, and stopped there. If you manage to survive this section, though, the real gold begins. The main stars of this chapter are if, switch, and the ternary operator. And with those, the author absolutely nails it. It all starts with if, and it's honestly a joy to read. Tons of examples, tons of diagrams, tons of explanations, control flow, nested ifs, if-else chains, a standalone else, situations where one if lives inside another. Everything is shown, broken down, and spoon-fed in a good way. It's just pleasant to go through. Out of nowhere, though, he suddenly throws in a section about functions from C type. And that part is definitely out of space. We still don't know what functions are or why we need them. And suddenly we're looking at a whole bunch of functions like check if this is a ladder, check if this is a white space, check if this is a digit, and so on. He goes through basically everything that's in that header, maybe 15 functions, and dumps examples on us. If you mentally treat functions as some kind of commands, you can sort of swallow it, but inside this particular chapter, it clearly doesn't belong. Stuff like that is much better explained after we've properly learned functions themselves. The good news is that detour doesn't last long, and soon he comes back to if. And here he drops even more great material, logical operators and or not, plus a huge set of examples that show how everything works together. This is the kind of thing I want from the textbook. A lot of practice. He shows simple conditions, more complex combined conditions, explains what happens if you just stick a number into an if, compares logical operators to bitwise ones, explains short circuit evaluation. Everything is clear, concrete, and to the point. Then comes the ternary operator. He shows the syntax, how it replaces a simple if, where it makes sense to use it, and where it just makes code harder to read. Overall, that section is also very well done. The last big part is switch. Again, we get a big pile of examples. He explains what labels are, why you need break, what you're allowed to put inside the parentheses, and what happens if you forget a break. He shows the default label and even fall through. Even though we technically haven't talked about attributes yet, he presents it gently without groaning the reader in jargon. He also shows that you can declare variables directly inside if and switch conditions, explains why you might want to do that and why, in some switch cases, you're not allowed to declare variables, plus how to work around that. Then he gives examples of switch working together with enumerations, and he wraps everything up with 8 big exercises so you can really lock the material in. And honestly, this chapter is excellent. It's not perfect. I'd move the section with the functions further down the road and definitely wouldn't torture beginners with a deep dive into the spaceship operator this early, but everything else is fantastic. Tons of examples, explanations from every angle, everything is visual and lively. If all the chapters were like this one, I'd be absolutely thrilled. Just bravo. Chapter 5. Arrays and Loops. In this chapter, the author covers 2 big topics, one-dimensional arrays and loops. Right away, I didn't love this structure. He starts with arrays and only then moves to loops, while I'm used to seeing loops first. Usually while, then do while, and only after that for. The array explanation itself is fine, but but tying loops to arrays from the very beginning feels unnecessary. Loops could have been useful much earlier, even with simple variables. On top of that, he starts with a for loop, which is the most complex one syntax-wise, instead of easing the reader in with simpler loops. Another thing I didn't like is his use of size t instead of int without properly explaining why. He mentions that size t is related to size of, but never clearly connects it to loop counters. That leaves a very natural question unanswered. Why not just use int or unsigned int? Then he gives coding advice like avoid magic numbers, which is good, but immediately contradicts himself by using auto instead of double in a simple example. He also initialized a count variable with empty braces, which technically sets it to 0, but is far from obvious for beginners. The for loop itself is explained well with diagrams and lots of text, but the example code feels unnecessarily confusing. Instead of moving on cleanly to other loops, the author jumps back to arrays again, showing how to create arrays without explicitly specifying their size and how to get that size using std size or size of. The explanations are fine, but the constant back and forth between arrays and loops makes the chapter feel scattered. I would have preferred one solid section fully about arrays and another fully about loops. That said, I do like how carefully he analyzes real programming pitfalls like comparing floating point numbers. A big plus is the section on the comma operator. He clearly explains that it's a binary operator and even shows a tricky example so you understand how it works. I genuinely like that level of detail. He also introduces the range-based for loop and even mentions things like optional initialization, which was new to me. He explains it well enough and promises to return to it later, which makes sense since the lower level details require knowledge of containers. After that, he finally explains while and do-while loops and does it well. Syntax, examples, execution flow, diagrams. Still, forgets way more attention, and while never gets a really strong use case example, which might leave beginners wondering why they need it at all. Then he talks about nested loops, but starts with a very large example. I think that's a mistake. It would have been much clearer to build up from simple cases. Next come continue and break. He correctly points out that continue is almost always unnecessary and that break, while sometimes useful, is often worse than writing clear loop conditions. He also covers a very common bug with unsigned loop counters where subtracting from 0 causes underflow and shows multiple ways to fix it, including the C++ size function. Toward the end, the chapter shifts to strings. He explains character arrays, C-style strings with the null terminator, memory layout, string literals, and basic input-output with cin. Since methods haven't been introduced yet, he asks the reader to treat them as simple commands for now, which is a reasonable approach. Then he goes deep into multidimensional arrays, how to create them, initialize them, index them, and work with character matrices with solid examples. Finally, he briefly talks about variable length arrays on the stack, explaining that they're not part of the C++ standard and won't work in Visual Studio. He mentions that dynamic memory will be covered later, which is good context. The chapter ends with an introduction to std array and std vector. Even though the reader doesn't yet know templates or classes, the author is upfront about that and focuses on practical usage. He does a good job here and strongly recommends using std array instead of raw arrays. The very last topic is using ranges and formatting to print containers, showing a few different ways to do it. Chapter 6: Pointers and References. This chapter is about pointers, which are traditionally considered one of the hardest topics in C++. The author starts with the basics: what a pointer is, how it's stored in memory, and how it points to a variable. He uses diagrams, shows how to declare pointers, explains the different ways to place the asterisk, and warns about declaring multiple variables on one line, where it's easy to accidentally create a regular variable instead of a pointer. He also uses Hungarian notation, which is rarely used in real projects, but here it makes sense for learning. The chapter explains that a pointer size doesn't depend on the data type and is always 4 or 8 bytes depending on the platform, and even shows code to verify this. Next, the author introduces the ampersand operator, which lets you get a variable's address and assign it to a pointer. This is explained visually, and at the same time he talks about using auto with pointers and actually recommends doing that. I don't agree with this advice. Auto makes sense for long or complex types, but for simple pointers like int asterisk, it hurts readability more than it helps. Around the same time, void asterisk is mentioned in the context of printing addresses, but it feels rushed, and I think this topic should have been explained separately and earlier. After that, there is a large example with lots of pointers and referencing. Technically, it's correct, but the example itself is weak. There are too many pointers, they don't solve a real problem, and they only make the code harder to read, which raises the question of why pointers are even needed there. On top of that, the author constantly uses brace initialization instead of simple assignment, which is personally find less readable. There's also an example where dereferencing and multiplication are combined in one expression, so you end up with a lot of asterisk characters in one line. The author does explain how to read it, but it's still hard to follow. Then the chapter goes deep into char asterisk, string literals, and character arrays. The author shows assigning a string literal to a pointer, but doesn't immediately mention that this won't compile in Visual Studio, even though Visual Studio was clearly used earlier in the book. A very important detail is also missing here. String literals live in static memory, while the pointers themselves usually live on the stack. What is explained well is the role of the null terminator and why printing a char asterisk or a character array without null terminator can result in garbage output. The author also introduces arrays of pointers and explains why they're useful, for example, sorting strings by swapping pointers instead of copying entire strings. The section on const correctness is one of the strongest parts of the chapter. The differences between a pointer to const, a const pointer, and a const pointer to const are explained clearly, and the examples really help make the distinctions stick. After that, const pointer are arithmetic, including adding and subtracting integers and subtracting one pointer from another. The author explains this using the idea that pointers are treated like pointers to arrays. It's an interesting explanation, but not entirely accurate, and in general, I think pointer arithmetic should be used very carefully, if at all. A large portion of the chapter is dedicated to dynamic memory. The author explains why it's needed, how to use new and delete keywords, how to work with arrays, including multidimensional ones, and introduces null PTR. Multidimensional arrays are shown using the classic approach with an array of pointers. What I like here is that the author clearly says that this is not how you should write modern C++ and points to std vector as the correct alternative, while still emphasizing that you need to understand how things work under the hood. After that, the book covers creating objects on the heap and calling their methods through pointers using the arrow operator. This part is straightforward and doesn't cause any issues. Then the author talks about common dynamic memory problems like memory leaks, losing pointers, and fragmentation, with the correct takeaway that if you use new, there should always be a corresponding delete, or you should rely on tools that manage memory for you. The most controversial part of the chapter is smart pointers. The author introduces unique PTR, shared PTR, and briefly mentions weak PTR, but does this too early before the reader really knows how to design their own classes properly. On top of that, he says real-world examples will come later, which makes you wonder why this topic is explained in so much detail right now. Weak PTR is postponed to later chapters, and overall the section feels heavy and out of place. The chapter ends with references, and here everything feels appropriate. It's a light topic explained at just the right level, with a clear note that their real power will be shown later. Overall, the chapter contains a lot of valuable information, but it's held back by overloaded examples, questionable recommendations, and a poor ordering of topics, especially when it comes to smart pointers. Chapter 7. Working with Strings. This chapter is almost perfect, kind of a benchmark, because it's completely focused on working with strings. First, we'll learn what a string actually is, then we'll get introduced to the std_string class whose methods we'll be using all the time. We'll see how to create objects of this class, how to initialize them, copy them, print them to the screen, read them from the keyboard using getLine, concatenate them, search for substrings and characters using different methods, delete and replace parts of strings, clear everything, get the string length, understand how that length is defined, and much more. Why almost perfect? Because it focuses on just one class, basically std_string, but not completely. Some of its methods are tied to the STL library, and since we haven't studied that yet, the author didn't go over the entire class. If he had covered it fully, I'd definitely call it a perfect chapter. Still, he even explained most of the overloaded methods, which is great. Later in the book, we'll get to know other classes that work similarly to std_string, like std_wstring and so on. We'll also learn that std_string is actually just an alias for std_basic_string. Then we'll find out what raw strings are, strings where escape sequences don't work. And at the end, there are lots of interesting and moderately challenging exercises. Chapters like this are always super enjoyable. Oh, and I almost forgot, the author also shows how to convert different data types into strings and how to convert numbers stored as strings back into actual numeric data types. So yeah, it's a really good, engaging, and easy to follow chapter. Chapter 8. Defining Functions. This is an excellent chapter, almost a perfect one, and here's why. The author focuses almost entirely on functions, and that's incredibly important. Once you truly understand functions, your code changes dramatically. You start using them everywhere. Your programs become cleaner, more readable, and much easier to reason about. You stop writing everything in one place and begin structuring your logic properly. In this chapter, the author explains what functions are and why we need them, where to write function prototypes and where to put definitions, the difference between parameters and arguments, how to pass data by value, by reference, and by pointer, how to return values normally by reference and by pointer, and how to call functions, and how to write them in a clean, correct way. The chapter is packed with practical advice. The author regularly points out common mistakes, explains why there are dangers, and shows better alternatives. He also talks about the parameters of the main function and how to process them, although he doesn't explain how those parameters are actually passed to the program, which I think is a small downside. After finishing this chapter, you really understand why functions matter and you naturally start using them everywhere. In that sense, the author did an excellent job. However, there is one controversial part. Near the end of the chapter, the author suddenly dives into const correctness in C++, including const, const_expr, const_init, and const_eval. He talks about constant functions, constant variables, and values computed at compile time. This is a complex and fairly advanced topic, especially with features introduced in C++20 and C++23. Personally, I think this should have been a separate chapter, placed much closer to the end of the book. To really understand const correctness, it helps to first be comfortable with things like object-oriented programming. Introducing it here makes the chapter heavier than it needs to be. That said, the chapter will end with a large set of challenging and interesting exercises, and overall it leaves a very strong impression. If I had to summarize it, this is one of the best chapters in the entire book and quite possibly the best one. Chapter 9. Vocabulary Types. This chapter is much shorter. In it, the author talks about 4 standard library classes: std_optional, std_expected, std_stringview, and std_span. Each one gets its own section with several solid examples, plus practical advice on where to use them and which older types they can replace. Overall, I think this chapter is excellent. The explanations are clear, the examples are well chosen, and you come away with a good understanding of why these types exist and how they solve real problems in a more modern and generic way. That said, just like in some other chapters, there is a small issue. The author refers to these types as vocabulary types. Personally, I don't really agree with that term. I don't see a strong connection to the idea of vocabulary. To me, these are more like helper types, utility types, or tool-like types. Things that make code safer, cleaner, and more expressive compared to what we had before. They solve common problems in a more general and elegant way, but calling them vocabulary types feels a bit forced. Still, that's a minor nitpick. Overall, the chapter is strong and very useful. Chapter 10. Function templates. This chapter sticks to one topic as well, function templates. The author explains that templates are a huge subject and he's going to cover them across several chapters, not all in a row, but he does the right thing by starting with the basics, what a function template is and why we need it. In this chapter, you learn how to create templates, how to define template parameters, and how to give those parameters default values. You'll also see how the auto keyword can simplify template code in certain cases. On top of that, the chapter digs into a bunch of technical details around how templates actually behave and what the compiler does with them. Later on, the book will move into class templates and the heavier stuff, but for now, I think the author did a great job. He introduces a lot of important concepts, and even if not every example is perfect, you definitely walk away understanding how templates work and why they matter. Most importantly, he explains the purpose behind templates, what problems they solve, how they let us write more flexible and reusable code, and how templates allow certain logic to live entirely at compile time instead of runtime. Overall, it's a strong, focused chapter and a great introduction to one of the most powerful features in C++. Chapter 11. Modules and Namespaces. This chapter isn't as focused as the previous ones. Here, the author talks about namespaces and modules. Let's start with namespaces. They're explained pretty well. You get a few examples, the idea is clear, and most of the important points are covered. The only downside is that the topic isn't fully closed. For example, the author never mentions unnamed namespaces. Still, most of the material is solid and makes sense. Modules, though, that's where things get messy. The first issue is that even today in 2026, the C++ standard still doesn't define what file extension a module should use. As the book points out, different compilers pick different naming schemes, and that already makes things confusing. Second, and this is the bigger problem for me, the author introduces modules before talking about header files. That feels backwards. For decades, all the way up to C++20, developers used headers, and most still do. So the logical teaching order, in my opinion, is 1. Show how headers work, and then 2. Explain here's how modules replace them in modern C++. But the author jumps straight to modules. Even though I already know a lot of C++, I found myself tripping over details simply because modules aren't something I use every day, especially not in Visual Studio. You can get them working there, but you need to tweak project settings, flip a few switches, and maybe read up on how the IDE handles modules. It's not hard, but it's definitely not plug and play. Another problem is how the material is presented. At times, the explanation feels unclear, like the author gets lost in the technical details, and I ended up getting lost with them. A few times, I caught myself reading paragraphs and realizing I had no idea what they were trying to say. Maybe I was just tired, or maybe the writing really was muddy, hard to say. Whatever the reason, for me, this was the hardest chapter so far, simply because it introduced a lot of new material, not conceptually new, since I've seen modules in earlier editions of this book, but new in the sense that I've never really used them in practice. To be fair, the author relies on modules throughout the entire book, starting from the chapter 1, so clearly he thinks They matter, and I get it. Eventually, modules will replace header files because they're cleaner and easier to manage. They're the direction modern C++ is heading. But after finishing the chapter, I actually wrote myself a note. Learn modules separately. I know that at some point I'll dig deeper into them on my own, and honestly, once I fully wrap my head around them, I'll probably make a video lesson about modules on my channel, hopefully explained in a clearer way. Chapter 12. Defining your own data types. This is one of the most important chapters in the book. It's where real object-oriented C++ finally begins. The author starts with the fundamentals, what a class is, what an object is, and how OOP differs from procedural programming. The explanation is clear, but there's a small flaw. Procedural style is described without concrete examples, even though that's exactly what we'd been writing up to this point. He then introduces the core OOP principles, encapsulation, inheritance, and polymorphism, and treats data hiding as a separate concept. I don't fully agree with that breakdown. Personally, I see data hiding as part of encapsulation, and I'd include abstraction as the fourth pillar. Still, the conceptual explanations are solid and presented first through diagrams and plain language before touching C++ code. Polymorphism, however, only gets a quick preview rather than a deep dive. Eventually, we reach actual code and meet the famous box class. Unfortunately, boxes dominate nearly the entire chapter. Reusing one class for everything makes the examples feel repetitive. A mix of different domains would have shown the flexibility of OOP much better. Using box, the author covers fields, methods, and the class versus struct distinction. The explanation is technically correct, but the teaching order feels debatable. He presents everything at once instead of gradually evolving from C-style structs into full classes. From there, the chapter becomes dense and highly technical. Object creation and method calls, multiple forms of initialization, including modern techniques, constructors, default, parameterized, initializer list, explicit, delegating and copy constructors, deleted functions, destructors, static members, const correctness again, this pointer, including a C++23 twist, mutable, friend, object size, arrays of objects, const expr, const evil, again, smart pointers, again, and a preview of RAII or RAI. The constructor section is strong and practical. The destructor section, however, feels too soft. I would have preferred a raw pointer ownership example to make the lifetime rules more concrete. And one odd moment, he mentions union, says he won't cover it, recommends variant, and then doesn't explain that either. That felt unfinished. The biggest disagreement I have is with his decision to focus on modules instead of header files. Modules are modern, yes, but headers still dominate real-world C++ projects. I think headers should have come first, with modules introduced later in a dedicated chapter. The most controversial part of the chapter is the massive truck and box linked list example. This is easily the longest example in the book. The problem isn't the explanation. There are plenty of diagrams and step-by-step walkthroughs, but the cognitive load. Two complex topics are introduced at once, implementing a linked list and modeling a non-trivial domain with trucks and boxes. I think it would have been cleaner to first build a list of simple integers, then generalize it. To make things heavier, he suddenly introduces random number generation. I mean, std random device, engines, distributions. Inside that same example, randomness is a big topic on its own. The author admits it'll be covered properly later, so this part feels like a rushed preview rather than a necessary addition. Near the end, he adds nested classes and then implements a custom iterator for the box list. Personally, I'm not convinced this was the right place to introduce iterators. For such a small container, it feels like abstraction for abstraction's sake. I would have preferred seeing iterators through the STL first and only then building one manually. The chapter ends with 9 exercises, some strong, some fairly standard. Overall, this chapter is ambitious and packed with material. It covers a huge portion of what it means to write class-based C++ code. The technical content is solid, but the pacing and structural choices are sometimes questionable. Still, it's a foundational chapter and an important turning point in the book. Chapter 13, Operator Overloading. This is a really solid chapter. It's fully focused on operator overloading. No random side topics, no distractions. The author starts by explaining why operator overloading matters and where it actually makes sense to use it. He shows how overloaded operators can make your code cleaner, more expressive, and more natural compared to regular function calls. Then he lists which operators can be overloaded and walks through them step by step. He covers arithmetic operators, type conversion operator, the function call operator, shift operators, and other key cases. What makes this chapter strong isn't just the technical how, but also the architectural advice. It's not only about how to overload operators, but when it's appropriate and how to do it properly. The only downside is that he keeps using the fucking box class again, which makes the examples feel a bit repetitive. He also skips some very rare operators, like the comma operator, but all the important ones are covered. Overall, it's a tight, well-structured chapter with solid examples and practical insights. Great work by the author. Chapter 14, Inheritance. First, the author is still using the same fucking box examples. At this point, it's been 3 chapters in a row. The issue isn't just repetition, it's that the examples don't expand the reader's thinking. If everything revolves around boxes, you don't really develop intuition about when inheritance is actually appropriate. The real projects, nobody designs systems around boxes. You deal with users, vehicles, services, devices, real domains. A wider range of examples would have made inheritance feel like a practical design tool instead of just a syntax exercise built on the same toy model. Second, the chapter feels too short and not deep enough. Usually the author tries to be thorough. Here, surprisingly, the coverage feels thin. Some important aspects are either skipped or barely mentioned. Inheritance access specifiers in more depth, the structured behavior in inheritance hierarchies, static members in base and derived classes, operator overloading in inherited context. Most of the fundamentals are explained. You'll understand what inheritance is, why it exists, how to derive one class from another, what protected means, what multiple inheritance is, and what virtual inheritance is. But even virtual inheritance is treated mostly at the surface level. There's no explanation of what happens under the hood, how virtual-based classes affect object layout, how the diamond problem is resolved internally, or why adding the virtual keyword changes the memory structure. That's exactly the kind of detail that often comes up in technical interviews. In my own lessons, I spent hours breaking down how virtual inheritance works internally. Here, it feels compressed into maybe 20-30 pages, which isn't enough for a topic this subtle. So overall, I didn't enjoy this chapter. The repetition limits conceptual growth, and the lack of depth makes inheritance feel simpler than it really is. Still, the core ideas are covered, and if the box examples don't wear you out, you'll walk away understanding the basics. The book overall remains strong, so we move on. Chapter 15, Polymorphism. This chapter suffers from many of the same issues as the previous ones. Polymorphism is a fundamental concept in programming. It's something that comes up in almost every technical interview, and it's absolutely essential to understand. That's why I expected a more structured and comprehensive treatment of the topic. One major issue is that the author presents polymorphism almost exclusively as subtype polymorphism, inheritance with virtual functions. But in C++, there are three forms of polymorphism: ad hoc polymorphism, means function overloading; parametric polymorphism, means templates; and subtype polymorphism, means inheritance. It uses inheritance. Function overloading is polymorphism. Function templates are polymorphism. Even if templates haven't been fully covered yet, the distinction should at least be made. I would have preferred the chapter to clearly separate these categories and explain that what we are studying here is specifically subtype polymorphism. Instead, the entire discussion is centered only on inheritance-based polymorphism. And once again, we're stuck with the same box examples. By now, it's the third chapter in a row. This is more than just repetitive. It limits the reader's ability to build intuition. To really understand encapsulation, inheritance, and polymorphism, you need exposure to different domains and problem types. Otherwise, when a beginner finishes the chapter, they might reasonably ask, where would I actually use this in real code? I'm asking that question from the perspective of a new reader. I personally know where polymorphism is useful, but someone encountering it for the first time might not walk away with that clarity. Technically, the author does explain what polymorphism is, shows how to implement it, introduces virtual functions, and even discusses the virtual table pointer. At first, I was glad to see virtual tables mentioned. That's often an interview question, but the explanation felt incomplete. The virtual table is shown in the concept of a single class, which makes it unclear why it's needed at all. To truly understand its purpose, you need a class hierarchy with multiple derived types, each having its own virtual table. You need to see how different objects point to different function implementations at runtime. That connection isn't fully demonstrated. I've had interviews where I was asked to explain how the virtual table works internally. Saying it briefly mentioned here was promising, but the lack of depth was disappointing. The chapter also covers override keyword, final keyword, and RTTI. Runtime type identification. In C++, RTTI is typically accessed via dynamic cast and type ID. The explanation of dynamic cast is decent, but type ID feels underexplained. The general idea is there, but the treatment isn't thorough. So overall, this chapter contains useful material. The fundamentals are present, but the structure could have been clearer, the scope broader, and the depth greater. The content isn't wrong, it just feels incomplete and not presented in the most effective way. Chapter 16. Runtime Errors and Exceptions. This chapter is noticeably better. It clearly explains what exceptions are, how to create them, and how to use them with try, catch, and throw keywords. The author also covers the difference between throw objects and plain throw, walks through the standard library exceptions, and shows how to derive your own exception types from them. You'll also see no except, along with a brief mention of the old dynamic exception specification syntax. Personally, I think that legacy feature deserved a slightly fuller explanation, at least from a historical C++ perspective, but its inclusion is still useful. The chapter does a good job showing how to design custom exceptions and offers some guidance on when exceptions are appropriate and when they aren't. However, this is where the material feels a bit thin. Like several recent chapters, the author focuses heavily on the technical mechanics, but doesn't provide enough strong real-world usage scenarios. Beginners may still struggle to develop intuition about when exceptions are the right tool. One nice modern touch is the introduction of std stack trace from C++23, which lets you inspect the call stack that led to an exception. That's a valuable addition and definitely worth highlighting in practice. Overall, this is a strong chapter. The lingering box examples are still there, but at least they're used more sparingly this time. Chapter 17, Class Template. This chapter focuses on class templates. In chapter 10, we already learned about function templates, and now we move on to the next step, creating template classes. The author starts by explaining the core idea behind class templates, why they exist, and what problems they solve. After that, he introduces the syntax for declaring template classes, walks through the key concepts related to them, and shows how to work with multiple template parameters. The main practical example in this chapter is building a template class called array. Throughout the book, we'll keep improving this class step by step. Essentially, it's a container that stores multiple elements of the same type, where the type is specified at compile time. First, the author shows all the methods the class will have and explains why each of them exists. Then we implement them one by one while discussing the syntax in detail, why certain pieces of code are written the way they are, and how templates interact with constructors and destructors. Along the way, the author talks about code duplication and introduces the don't repeat yourself or dry principle. To demonstrate this, he uses a fairly large example involving const cast. Normally, const cast is discouraged because it can break an object const correctness. However, in this particular case, it's used deliberately to reduce duplicated code and improve the overall structure. Next, the chapter moves on to overloading the assignment operator. Here, the author introduces the copy and swap idiom, explains it in detail, and strongly recommends using it regularly. It's a great example of how a small pattern can provide a much safer and cleaner solution than many naive implementations. After that, the author explains template class instantiation, why it's needed, how it works, and where it can be useful. One interesting thing I learned is that you can force the compiler to instantiate a template even if you don't actually use it in the program, just to check for compilation errors. Then, the chapter covers explicit template instantiation and adds more examples using our array class. After that, the author explains partial and full template specialization, again with several practical examples. One thing I really like about this chapter is that the author often starts with a solution that works and is understandable and then shows how it can be improved. That's an important skill for programmers. Even if your code seems fine, it's always worth asking whether it could be written in a cleaner or more efficient way. Later, the chapter discusses default template parameters and explains how the compiler deduces template argument types. In this context, we also learn a bit more about initializer list, which was only briefly mentioned earlier in the book. Toward the end, we implement another class that represents the abstract data structure stack. Internally, it uses a singly linked list. It's a good example of applying templates, although the author doesn't really explain why a stack is useful in real-world programming. Personally, I would have liked to see more practical examples showing where these structures are actually used. Overall, this is a solid chapter. By the end of it, you should be able to write your own class templates. And that's especially important because later in the book, we'll start working with the STL, where class templates are used everywhere. Chapter 18, Move Semantics. In this chapter, the author explains what L values and R values are. You'll clearly understand the difference between them and be able to identify them in code. Then the author talks about the problem of unnecessary copying and how it can be solved using move semantics. First, they introduce the move constructor. After that, they go over the std_move function in detail. You'll also get a lot of practical advice on how to use move semantics. The author even shows cases where instead of having two functions, one taking a const L value reference and another taking an R value reference, you can just pass objects by value and end up with cleaner code. I really liked how much effort they put into explaining this topic, showing different tricks and giving tons of useful tips. For example, you'll learn about the rule of 5 and the rule of 0, as well as which functions the compiler generates by default. The chapter also covers no except and introduces some metaprogramming concepts. Overall, it's a great chapter. Chapter 19. First-class functions. An interesting title. I've never heard this kind of terminology before. In simple terms, in this chapter, the author explains objects that can store functions, which allows us to pass functions to other functions. The author also explains why this is useful. Among such objects, we encounter function pointers, functors, lambdas, and std function. The author covers the topic very well, provides many examples, and offers plenty of practical advice. Personally, I understood everything and even noted some new information from the C++23 standard that I plan to use in my future lessons. You will also get acquainted with the concept of callbacks and learn how to create template aliases. Chapter 20. Containers and Algorithms. This is one of the biggest chapters in the book, and honestly, it tries to cover pretty much the entire world of C++ containers in one go. It starts off with the basics, what containers are, and then moves into their main categories. The focus is on sequence containers like array, vector, DAC, list, and forward list. The author explains how they work internally, what they have in common, and how you're supposed to use them. Then we move on to container adapters, stack, queue, and priority queue. Here he introduces the core ideas like LIFO and FIFO and shows a bunch of code examples. But the problem is he never really gives real-world use cases, so it all feels a bit abstract. After that, he dives into associative containers, set, map, multisap, and multimap, along with newer variations like flat, map, flat set, etc. He also touches on unordered containers. Technically, everything is covered, but not very deeply. For example, with flat containers, you kind of get that they use contiguous memory, but when and why you'd actually use them isn't really explained. The explanation of unordered containers is even weaker. There's barely any solid explanation of hash tables, hashing, or how things work under the hood. Overall, it feels like the author is trying to cram too much into one chapter, so everything ends up being pretty simple, even though there's a lot of code. Next comes iterators. First, he explains the concept itself and connects it to the iterator design pattern. Then he shows how iterators are used with containers in practice. He goes through different types, forward, bidirectional, read-only, writable, and so on, and also covers container methods that either return or require iterators. There's also a section on const iterators and special ones like back inserter iterators. One really important topic here is removing elements while iterating over a container. He explains what can go wrong and shows different ways to handle it, from the classic remove arrays idiom to newer approaches from C++20 and C++23. Then there's a big chunk about algorithm library, all those standard functions for working with containers. There are tons of them, like over 100, so he only shows a selection, but in different combinations and problem scenarios. And finally, we get to ranges and views from C++20. It actually starts off pretty clear, but once he gets into projections and views, things get confusing fast. The code suddenly looks way more complex, even though he says it's simple. I don't agree with that. This is definitely a part I'd need to revisit and study separately. The chapter ends with a huge set of exercises, literally several pages of just problem statements. Chapter 21. Constraint templates and concepts. I finally made it to the last chapter of this book after several months of reading, and honestly, it's probably the hardest chapter in the entire book. This chapter is about concepts. At first, the idea seems fairly straightforward, but as the author keeps adding more and more details, it quickly becomes overwhelming. At some point, it just starts to feel heavy and harder to process. Personally, it felt like my brain was overheating while trying to keep up with everything. I won't go deep into the specifics of the chapter. The core idea is using concepts together with templates. Concepts are a powerful and convenient feature, but in practice, most developers won't really use them much. To be blunt, about 99% of what's covered in this chapter probably won't be useful in day-to-day development. And even if it is, it'll likely be at a very surface level. As the author mentions, the standard library already provides a large set of ready-made concepts, so writing your own is pretty rare. That said, it's still worth getting a basic understanding of what concepts are and how they fit into template programming. It's also telling that the compiler, the chapter only includes 6 exercises, much fewer than in previous chapters. That reflects the nature of the topic. Concepts like templates are mostly used in low-level library development and are closely related to metaprogramming, which is a fairly advanced and complex area. And that's where the book ends. Appendix A: Preprocessing, ODR, linkage, and header files. It's also worth talking about Appendix A, which comes right after the final chapter. It honestly feels like this used to be a full chapter, but with the introduction of modules in C++, it was moved into an appendix. The main focus here is the comparison between header files and modules. The author points out that in practice, most projects still rely on header files, and that's hard to argue with. Even today, they're still the de facto standard. Personally, I think it would have made more sense to first properly cover header files earlier in the course and then dedicate a separate chapter to modules and their advantages. In this appendix, the author directly compares both approaches, and overall modules clearly come out ahead. That said, there are still some specific cases where header files remain more practical or simply more common. Beyond that, the appendix dives into the compilation process. The author explains how the preprocessor works, what steps it performs, and then goes deeper into linking and the role of the linker. This is fundamental knowledge that's often overlooked, but here it's explained quite clearly. There's also a detailed breakdown of preprocessor directives. The author goes through the major ones available up to C++23, explains what they do, and shows practical examples. After that, he covers predefined macros and discusses modern C++ alternatives that should be used instead. Importantly, he doesn't just criticize macros, he gives clear guidance on when they're appropriate and when it's better to use alternatives like global constants, variables, or function templates. The appendix also touches on core language concepts like the inline keyword, anonymous namespaces, and different types of linkage, external, internal, no linkage, and module linkage, all explained in a practical context. Overall, this is a very strong and accessible part of the book. Unlike the previous chapter on concepts, which felt quite niche and heavy, this appendix covers fundamental topics that every developer deals with from the very beginning. The author emphasizes that modules are the future, and I completely agree, but in reality, adoption is still slow, and most projects continue to rely on header files. And that brings us to the end of this book. Most likely some of you skipped straight to this part to answer the main question. Is this book worth reading? Short answer, yes, absolutely. It's one of the best C++ books available right now. And even when C++26 comes out, I don't think it's going to lose its relevance. The book's contains a huge amount of useful information that you'll need both for real-world programming and for job interviews. It also has a strong practical side, lots of exercises ranging from easy to genuinely challenging, which really push you to understand the material more deeply. Of course, it's not perfect. For example, parallelism isn't covered in much depth. Also, big O notation is barely discussed, even though it's important when working with STL containers, especially for interviews where you're often expected to explain why one container is more efficient than another. That said, this might also be my own expectations. I'm looking for a book that fully prepares you for entry-level positions like intern or junior, especially from an interview perspective. Even with those downsides, this is still an excellent book and I can confidently recommend it. If you decide to read it, try to go through it from start to finish and actually complete all the exercises. It makes a big difference. For me, this is the second C++ book I've covered on this channel, and it left a very positive impression. I've got another big one coming up next, and hopefully I'll get through it faster. My overall goal is to find and recommend 3 really strong C++ books. The previous book I reviewed was disappointing. This one was great. Now let's see how the next one turns out. Thanks for watching till the end. That's it for this review. If you enjoyed the video, feel free to like, leave a comment, and subscribe if you haven't already. You can also support the channel by becoming a member for access to practical lessons or by donating through the link in the description or via YouTube. Thanks. Thanks again, and I hope you keep reading great books. Goodbye.